Let us look at our frameworks. Okay, when you are given a framework like this, if it is necessary, you will calculate the reactional support. Okay, let's go ahead and calculate the reactional support. We denote this as our R1 and this as our R2. Now, when we calculate the reactional support, we will be using the law of moment. Yeah? Sum of the clockwise forces equals to sum of the anti-clockwise forces. Now let's emphasize few things. If the displacement, remember how do we calculate, how do we then apply? We use the moment equals to force multiplied by perpendicular. If the perpendicular distance it is not given, let's say you are not given the perpendicular distance on a framework, now you will be using the special angles. If this is your 30 and that's your 60, you will be using your special angles. Yeah? You will be using your special angles. You will be using your special angles as your displacement, right? This is 45, 45. Right. Now you will be using this pending how is it positioned. You'll be using this pending how it is positioned. For instance, if we were not given 1.5, we know that here it is 30. It is opposite over hypotenuse. So that means it is 1 over 2. Right. Then if we were not given any, it was going to be adjacent over hypotenuse, right? Adjacent over hypotenuse. Then we're going to use 1. We're going to use this one. It's adjacent over hypotenuse. We know that it is 1 over 2. Sine 60, it is 1 over 2. Then here we're going to write 1. Then, as per the position, then we are able to get those displacement and calculate thereafter. Right. Now, in calculating the reactional support here, taking moment here, we are having a downward force. It is force 40 multiplied by 1.5. It's rotating clockwise. We are having 40 multiplied by 1.5 plus 60 multiplied by 4.5. Because the distance from here to there, it is 3 plus 1.5, it makes it 4.5, equals to R2 multiplied by 6. Right, R2 multiplied by 6. Then our answer would be R2 equals to, now let's get a calculator. Where's my calculator? 2 minutes. My calculator. Right, found one. It will be 40 multiplied by 1.5 plus 60 multiplied by 4.5. Then it is 330. When you divide by 6, our answer it is 55 kilonewton. Now, we took moment at R1 determining R2. Our answer it is 55. Sum of the upward forces equals to sum of the downward forces. Now it will be R1 equals to 40 plus 60 minus 55. Our answer it is 45 kilonewton. Right. Now we managed to then calculate R1 and R2. It is 45 and 55. When we add the two, it must give us exactly what it's been applied on top of your framework. We can then go ahead and draw our vector diagram. Okay. We can then go ahead and draw our vector diagram. Right. I will write it nicely. We've managed to calculate them. Right. We can go ahead and draw our vector diagram now. Okay. Alright, this is our 45 R1. This is our R2 55. Alright, before we draw our vector diagram, we first have to name our space. This framework, it is called the space diagram. Meaning there's a space, there's a space, there's a space, there's a space in between, hence it is called the space diagram. We need to label our spaces, and in labeling our spaces we will be rotating clockwise. We'll denote this as our A, this as our B, this as our C, this as our D, then the inside would be the E, F, then we are having the G inside. When we label, we'll label it rotating clockwise, making a spiral like, right? In labeling our framework, our space diagram, right? Now, when we draw our framework, the first thing that we need to do is that we will represent all the vertical forces. We will be representing all these vertical forces. This force, this force, this force, that force, that force, that force with the vertical straight line. Now, where we are going to start, that's where we need to end to indicate that our beam, it is what? It is balanced. Okay. Now let's apply that which I'm saying. Right. Let's apply that which I'm saying. Let's get my writing tool. Okay. Let's get my writing tool. Right. Firstly, we have to choose a suitable scalar for us to be able to draw our vector diagram. Okay, we need to choose ourselves a suitable scalar. Now, let's rotate. Okay, let's rotate it further. Okay, is it straight? Yes. Okay. Now, where we are going to start, that's where we need to end. We will be using 10 centimeter is to 10 kilonewton. Yeah, 10 centimeter equals to 10 kilonewton. Scale. Right. Now we are having AP. AP is a force that it is going down. We are having AP. It's a downward force. What's wrong with my? It's what 40. Hey, what's wrong? Okay, let's do this. Right. We are having AB, it's a downward force, it's a 40. We'll put it somewhere there as our 40. Man. Oh my goodness, what's wrong with my writing tool now? Okay, let's wipe this. Right, started here going up. That's your 40. Right, that's our AB. Now let's make it like this. Come and make it like this. Yeah. Then we'll be using a small letter. That's our A. That's our B. Right. It's a downward force. Then we are having BC, it's a 60. BC, it's a 60. It will be 10, 20, 30, 40, 50, 60. Then I will start here going up. Right, start here going up. We have established where D will it be. This is where D will it be. This is where our D will be. Right. That's AB, BC. No, that's our C. That's our C. It is A. It is AB, downward force BC. Then we are having C point here. Right. Then we are having CD. CD, it's an upward force. It's a 55. It's an upward force, it's a 55. From here, 10, 20, 30, 40, 50, 55. This is where our D would be, 55 here. That's where our D would be. What am I doing with that one? This is where our D would be. Right. We are using Bohr's notation anyway. Right. Then we are having CD. Then we are having DA. DA. It's a 45. It's 5, 10, 20, 30, 40. Now, where we started, that's where we ended. This would be our DA. And when we count from D to A, it's a 45. This is your 5. This is your 10, 15, 25, 30, 45. Right. Where you start, that's where you need to end. That's exactly what we did here. We started there. We ended exactly where we are supposed to end. Right. Oh, it works the whole thing. All right, now let's. Right, let's. Okay. Ausweg, yeah. Now let us. Now, where forces starts and end, we will draw the horizontal line. Where forces starts and end, we will draw the horizontal line. Right, we will be drawing the horizontal line where forces starts and end. We want the horizontal line. Boom. Right. Where forces starts and end, we'll draw the horizontal line. Just drawing a horizontal line for us to be able to draw our vector diagram. Right. Forces started, then it ended somewhere here. Draw the horizontal line. Just draw the horizontal line. We are drawing them because we are bored. Not that there's anything serious regarding that. Right, drawing the vertical straight line. Shanana. Now we are done drawing our vertical, the horizontal straight line. Now, when you look at AE is a force. Let's do it this way. You are having something like this. First quad, first, second, third, and fourth. Now, when you look at AE, it's a force that it is slanting on first and third quad. It's a diagonal force, yeah? AE. Now, if AE, do we have the point E? No, we don't have. But do we have the point A? Yes, we have. If we make point A our reference point, there's our point A. But now, the point A to where this line is, you can check, you can tell that the angle there, it is 30. If this is 60, this would be your 90, then that would be your 30. And that would be your 30. That means I'm having 60, 60, 60, 60, 60, 60, 60, 60, 60, 60, 180, 60 here, 60 here, 180. When we make A our reference point, we will be able to get that force there. Okay, we will be able to get that force. Right, we take our protractor, we measure the 30-degree from the A, we measure the 30-degree. We make A our reference point. If A is our reference point, okay, let's take this side. If A is our reference point, we then have to measure the 30-degree angle. Right. Oh my goodness. It's never easy with people working with this instrument. It's never easy. But I will try my best. Then we have to measure the 30 degrees. 10, 20, 30. There's our 30 there. Boom. When we measure our 30, making A our reference point, that's what we have. Now, where A, now let's check. Our E, it's in common with what? It's a common letter. It's in common with D as well. Common with A. And DE, it's a horizontal straight line. There's our D. That means where this D and that line meet, that's where our E point would be. That's where our E point would be. Where they meet, that's where our boom. Yes. This point here, it is point E. This is our point E. E, it's in common. E, it's in common with A, it's in common with D. Now, where that point meet, that's your E point. It's your E point. Right. Now, we are done with this force. We are done with that force. Right. Let's look at the next one. We are having BF. And BF, it's a horizontal line. This is B. We are having F. F, it is somewhere here. We don't know where. But if we were to make B our reference, E our reference, because this F is in common with E, and we do have point E. Now, where E is to where that line is, the angle here, it is what? 60. And we do have point E. That means from point E, as a making E our reference point, we can measure 60 degrees. We can measure our 60 degrees there. We can measure our 60 degrees. Now we are having 30. There's our 60 there. Boom. We have our 60. Now we are having where this point touches the that's where your F point would be. Boom. We are having BF because where this and that meet, that's where your that's your point F, because when you measure from here to there it must give you 60 degrees. Let's see if we will be getting that 60. See, we are getting 60 from there to there. It is what? 60. Yes, that's point F. We are having point F there. That's point F. We are having F there. Right. B, F we have it. E, F we have it. F it's in common as well with G. Do we have point F? Yes, and it's a force that slants from 2. Now if we make F the reference point from where a G should be, we would measure from here to here. It is 30 degrees. Then we will measure 30 degrees. Measure 30 degrees. Let's put it this way. We are going to measure 30 degrees. Let's put it this way. Going to measure horizontal has to be our reference point. Now we are going to measure what? 30 degrees. Boom. This is where our 30 is. From that point to that point, it is 30. Boom. That is G. FG. FG, it's in common with D. That would be our FG. This is our small g. It's a small g. Then from here we are having CG. CG is a line from 2. That one it's easy straight to the point. Yes, we are just going to draw the straight line in connecting this dot. Boom. We are done with our framework, with our vector diagram. We are done drawing our vector diagram. We've drawn our vector diagram. I'm glad that we are done. We can wipe unnecessary lines. We are done. We are done, done and dusted. We are done. We are done. We can now determine the nature of our forces. Shouldn't forget that that's a B point there. Right. This is my A. That's my B. Right. Okay. We are done, good people. We can then now determine the nature of our forces. See, and okay, we'll get the ruler now. Now, whenever we draw the nature of our forces, I get a thick line a bit so that I can write nicely. On every point, on every joint, like here, I'm having a joint, I'm having a joint, I'm having a joint, I'm having a joint. This is just a point. Now, on every joint, you will rotate clockwise. For instance, in rotating clockwise here, it will be, the motion would be from A to E, 2. That's your clockwise motion. Same thing here, A, clockwise motion, clockwise motion, clockwise motion. That would be your clockwise motion. Now, if I were to rotate clockwise motion, I'm having AE. I'm having AE. Then I need to then determine the magnitude of AE. Don't forget that we said our 1 centimeter equals to 10 kilonewton. Then AE, where's AE? There's AE. All right. Now, the first thing that I'm going to do is to measure. I'm going to measure. I'm going to measure. I'm going to measure. We are going to measure, people. We are going to measure from there to where our E is. We are having 10, 20, 30, 40, 50, 54. Now, our AE, it is what? 50. It is 54. 54 kilonewton. Right, let's look at now the nature. How do we determine the nature? Now check here. How do we then determine the nature? We said AE. This is AE. Where is it heading down? It then means here. Let's change the color and make this blue or yellow. We are having AE. It's heading that direction there. This is where it's heading. The opposite, it is true, you are having an upward. And now let's help you out. If you are having something like this is your strut. If you are having forces converging, that's your tie. Okay. Now you can tell that here, the fact that here AE, as per the vector diagram, they said it indicates that it's going that direction. The arrow of it will be represented as such. All right. It will be represented as such, that it is heading that direction, AE. Okay. Now we will prove if this, what I just said, that the opposite is true, is it so now when we get to that point. Then we are having ED. Then we are having ED. We are having ED. Where's ED? ED. This is the line. Then we get to measure the ED, but it's a force that is going ED heading that direction. We are having ED, it's heading that direction. It's heading there. Opposite it is true. Already here you can tell it is your strut. Here it is your tie. That's what you have there. Then we are having DA. DA it's an upward force. Let's see. DA. Can you see that? DA it's going up. DA it's heading up. Right? That's what we have. ED we can measure and get the force there. Now let's come to that point there. I'm having AB. AB it's a downward force. I'm having BF. Now check here. BF. BF. BF it's heading that direction. BF. BF. That means here I'm having BF. The force it's heading opposite it is true. BF. Now then I'm having FE. FE. Let's see where's FE. FE heading that direction. FE. 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 That means here I'm having that because it's going down. It's only like that here. Now EA. 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 Let's see EA. EA. EA it's a force heading there. The opposite that I said it is true. That's what we have there. EA heading there. This is how you determine if it's a strut, or now you can tell strut. You are having tie here. You are having tie here. Then you continue. You are having CG. Now CG. CG it's heading that direction. CG. CG it's heading that direction. CG now. CG. 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 CG it's heading up. Opposite it is true. Right. Then we are having DG. DG. DG it's heading that direction. It is what? DG. DG heading opposite it is true. You are having tie, you are having strut, you are having da da da. Then you get to measure and write strut, tie, tie, strut as per the measurement. This is how you do that.